Okay, guys, so I'm going to do this problem. This is free response question 12. This is a non-calculator one. We'll start throwing in some calculator ones soon. Okay, so the function f is defined on the closed interval -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by this. So g is an accumulation function. And guys, right off the bat, it is very important to recognize, if you're dealing with an accumulation function, that its derivative is the input, okay, right there. That's important to recognize. So when you're looking at the graph of f, you are looking at the graph of g prime, that it is an immediate observation that we want to make. Okay, so part A, find g of 3. So the way that an accumulation function works is that you plug, okay, so let me go like right here. So for part A, for g of 3, for an accumulation function, the input goes up there. And I usually use W for the variable on the inside because it's hard to confuse it with X, but they're using T. So I need this area. So I want, oh, it's from -3. Where does -3 start? Oh, shoot, -3 is right here. So I actually didn't do it right when I did it earlier. So -3 is there. And we want this area all the way up to 3, which is right here. Okay, now, guys, you could ask, it's important probably to be in the habit of not just trusting that this is at a y coordinate of -2. You could verify it just using the slope of the line. So let me take a look at this line. The slope is 1, 2, 3, 4, down 4, right 2. So -4/2, that's the same as -2/1. So from this point, I could go, from this point to this point, I go down 2, right 1. So that would be down 2. So that is -2. All right, now let me do my areas. Okay, so 1/2 base times height. You could do the whole triangle actually at once if you want, guys. I'll do 2 separate ones just in case I need to separate them later. I don't think I do though. But the base is 1, 2, 3. The height is 4. 1/2, 3 times 4 is 6. The base is 2. The height is 4. 1/2, 2 times 4 is 4. And then this one, 1/2, 1 times 2. So that area is 1. Okay, so we're adding up the area. So it's 6 plus 4 minus 1 below the x-axis, so it's a negative area. So that's 9 is the first one. Okay, now the second one. This is a Susan's table one, guys. We really need to nail the Susan's table ones. So on what open intervals contained in the interval from -5 to 4 is the graph of G both increasing and concave down? So for G to be increasing, we need G prime greater than 0. For G to be concave down, we need G prime is decreasing. That's all from Susan's table. Okay, so we are looking, oh, and by the way, guys, F is G prime. So when we're looking at the graph of F, we're looking at the graph of G prime. So we're looking for where this graph is both above the x-axis and decreasing. So above the x-axis and decreasing would be this blue part and that blue part. All right, so this is part B. So the answer is from -5 to -3. Oh, you can't see, sorry. Union from 0 to 2. And then the reason needs to connect that F is in fact the graph of G prime, and then what aspects of the graph are telling us, that G is increasing and concave down. So I'll be like this, and I'll say because F is equal to G prime, so G prime is both positive and decreasing on these intervals. Okay? Alrighty, now the next one. Okay, so this next one here. The function h is defined by this. Okay, find h prime of 3. So guys, we're going to need the quotient rule. So this is part C. So I'm going to have to find h prime of this. So h prime of x, derivative of the top is g prime of x. Then bring over the bottom, 5x, minus, bring down the top, derivative of the bottom is just 5, all over 5x squared. Okay, now we're going to plug in 3. So h prime of 3 is g prime of 3 times 15 minus g of 3 times 5 all over, if you plug 3 in here, you get 15. You plug 3 in here, so you get 15. 15 squared is 225. Okay, now we just need to know what g prime of 3 is and what g of 3 is. Well, guys, the great news is that, well, for g prime of 3, guys, this is the graph of g prime. F is the graph of g prime. So if I want g prime of 3, I just get the y value of this graph. So 1, 2, 3. Oh, and we already figured out it's -2. We had to do that earlier. All right. So in for g prime of 3 is going -2. Now g of 3, we already found in part A. That happens a lot. So that's 9 times 5, all over 225. Okay, and then guys, you just do the math, and I had the answer already. It's -1/3. If you don't end up simplifying it though, that's okay. Oh, something that you could do, guys, I showed you this trick in the last one. If the algebra seems kind of heavy, or the arithmetic, you could like factor out a 5 or something if that would make it easier for you. But a lot of people don't like to do that. All right, that's part C. Now part D. The function p is defined by this right here. Find the slope of the line tangent to the graph of p at the point where x is equal to 1. Trying to get a good focus. That's hard. So guys, the slope of the tangent line, to the graph, that is the derivative. So we need to find the derivative of this and plug -1 in. So this is part D, and this is a chain rule situation. Chain rule is in and out. Okay, the derivative of the inside is 2x minus 1. The derivative of the outside is f prime, and then you plug that back in. All right, so this is p prime of x, and we want p prime of -1. P prime of -1. So you plug -1 in there, you get -3. You plug -1 in here, and you get 1 minus -1, so you get 2. Now we just have to find f prime of 2. Well, we don't have f prime, but we do have the graph of f. Right, we do have the graph of f right here. And to find f prime, if you have the graph of f, To find f prime, you just do the rate of change. You just do the slope at that point. So they want f prime of 2. Well, 2 is right here. And actually, guys, I kind of already said it. The slope of this line is negative, no, is negative 4 over 2, is negative 2 over 1. Right, that's the slope of that line. You go down 4, right 2. That's negative 4 over 2, that's negative 2 over 1. So this is negative 3 times negative 2, that's 6. Guys, I know it seems like tricky, but that was pretty straightforward, okay? So if you feel like you couldn't do that, if you've got the time, guys, I would do the whole thing from scratch again, because I think it's all but certain you're going to have a free response problem that is a pretty straightforward one like that. You just have to have strong skills, and you have to know how to switch between accumulation functions, derivatives, you know, their relationship, etc.